Hello, this video covers section 10.5 from your text, and we're going to be looking at some applications of quadratic equations. First, we're going to be looking at some area-related problems, areas of shapes that we see from geometry, like rectangles and triangles. And then we're also going to use the Pythagorean Theorem to solve some application type problems. So let's first take a look at the applied geometry type problems. And we have an example here. It says the width of a rectangle is 5 inches less than its length, and the area of the rectangle is 80 square inches. Find the length and width of the rectangle rounded to the nearest tenth of an inch. So just like any application problem, we start out with what we're given. What are we given in this problem? And you'll see right off the bat that because we know this is a rectangle, it might be a good idea to start with a picture of a rectangle. Start with a picture of a rectangle. We know that rectangles have lengths and they have widths. And it says in this problem that the width of the rectangle is 5 inches less than the length. That's the first sentence. The width is W, is. Now, do you remember what the word is means? What mathematical symbol is represented by is? You should say equals. We've talked about that. So when I say width is, that's W equals 5 inches less than the length. And a lot of times there's a tendency to write this as 5 minus L. But with subtraction, whenever you see less than, it's the other order. So in this case, it's going to be L minus 5. Okay, so that is the first thing that's given, is that the width is 5 less than the length. And then the second thing that's given is that the area, it says right here, the area of the rectangle is 80 square inches. So we're given that the area equals 80 square inches. And it asks us to find what? What are we trying to find? We're given that information. What are we trying to find? We're trying to find the length, what the length is equal to, and find what the width is equal to. Find the length and width of the rectangle. So what do we need to be able to do this? What's our relationship between area and length and width? We should know that area of a rectangle is the length times the width. Well, now what can we do with that equation? We can plug in what we know. We know that the area is 80. We have L, and then we know that W is equal to L minus 5. So we can write this as L, instead of L times W, we can write it as L times parentheses L minus 5. And now if we want to solve an equation like this, we should get rid of the parentheses first. So we have L squared minus 5L. And you should recognize here that this is a what kind of equation? It is a quadratic equation. That's why we're doing these type of applications in this chapter. And so we end up having then to put it in the ax squared plus bx plus c form, which makes it L squared minus 5L minus 80. And at first glance, it doesn't look like this is going to be factorable. I don't think that it is. So we're going to go ahead and use the quadratic formula. L equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 a, which becomes 5 plus or minus the square root of 25 plus 320, which is 5 plus or minus the square root of 345 over 2, which is really two answers, and said to round to the nearest tenth of an inch in our problem. So let's go ahead and get a decimal approximation for the square root of 345. Square root of 345 by my calculation is about 18.6. So this is 5 plus or minus 18.6 divided by 2, which is 5 plus 18.6 over 2, and it's 5 minus 18.6 over 2. The first one comes out to about 11.8, and the second one comes down to about negative 6.8. And one of those answers doesn't make sense in our problem, and of course it is the negative answer. We don't end up with lengths that are negative, so we'll go ahead and throw this answer out. That means that our length, the length of the rectangle, is the answer we just found. It's the 11.8 inches. And the width, that our problem said was 5 inches less than that. So 11.8 minus 5 is equal to 6.8. So the width is 6.8 inches. Okay, so that's our first example. Our second example has to do with area as well, but here we're going to talk about the area of a triangle. So let's again take the same approach. Let's go ahead and write down what's given in the problem. It says that we're talking about a triangle this time. So if I go ahead and draw my triangle in, it says the base of the triangle is 5 inches more than the height. So whenever we have a triangle here, this is the height, and this would be the base down here. And so it says the base of the triangle is, so again, that is means equals, so base equals 5 more than the height h. When it says the base is 5 more than its height, that's 5 plus h, or you could write h plus 5 if you wanted. And then the other piece of information that's given is it says that the area is what? The area is 42 square inches. And it's asking us to find what? It's asking us to find the base. It's asking us to find the height. So again, just like in the last problem, we now need a relationship that relates the base and height of a triangle to the area of a triangle. And if you remember from geometry, we learned that the area is the base times the height divided by 2. And then just like in the last problem, we can go ahead and plug in what we know. We know that the area is 42. And we don't want to have two separate variables in this equation, or we're going to have a difficult time solving. So again, we make that substitution. Because b is equal to 5 plus h, I can plug in 5 plus h for b, and remember, whenever we substitute something in, we put parentheses around it and multiply that still by h over 2. And here we get an equation that has a fraction in it. anytime this semester when we've had equations that have fractions in them, what do we do to get rid of the fraction? We multiply by the least common denominator, which in this case is 2. Sometimes students like to write as 2 over 1. If we do it on the right side, we also have to multiply it on the left side. On the right side, the 2's cancel. And so we are left with 5 plus h times h. At the left-hand side, 2 times 42 is 84. Now we got parentheses again. 5 times h is 5h. Plus h times h is h squared equals 84. And again, what do you know? We have a quadratic equation. Let's go ahead and put it in the form that we need to solve. So let's write the h squared first and then the positive 5h. And then when we move the 84 over, it becomes a negative 84. And now we got, oh, I don't know how that 5h became a 54, but that should be a 5h there. Turns out that this one is factorable, and so we can rewrite it as 0 equals h plus 12 times h minus 7, which gives us h plus 12 equals 0, and h minus 7 equals 0, which gives us h equals negative 12, and h equals 7, which means the base is 5 plus 7, or 12 inches. So we got that the height is 7 inches. Of course, we don't want to use that negative height. And then the base of this triangle is 12 inches. So there is the second example. Okay, so that brings us to the second main concept of this section. That's problems using the Pythagorean Theorem. So let's remember what the Pythagorean Theorem is. It says for any right triangle that has a hypotenuse of length c and has legs of lengths a and b respectively, we have the relationship that a squared plus b squared equals c squared. Sometimes people will say that as leg squared plus leg squared equals hypotenuse squared. And anytime we do have a right triangle, we do have to have a right triangle here. And a right triangle just means that there's an angle that's 90 degrees. When we have a right triangle, the Pythagorean theorem says that the two short sides, the sides that share the 90-degree angle, that would be A and B, if I add those legs squared, each of those legs squared, if I add them together, then they are equal to the long side of the triangle, the side that's opposite the 90 degree, that side squared. And so we have an example here. We have a right triangle, has a hypotenuse that measures 17 inches. Let's draw our picture. Write down what's given. This time we know we have a right triangle. We are given that the hypotenuse, the long side, is 17 inches. And one of its legs is 9 inches long. So we might say that this side right here is 9 inches. Find the length of the other leg to the nearest tenth of an inch. Let's call this other leg x. We don't know what that is. Then the Pythagorean theorem says that x squared, leg squared plus leg squared, 9 squared, equals the hypotenuse squared. And so then all we really have to do is simplify. We know that x squared plus 81 is equal to 289. We're trying to solve for x squared, so we can subtract 81 from both sides, which gives us that x squared is equal to 208, and that means that x is plus or minus the square root of 208, and we need to round that to the nearest tenth of an inch. The square root of 208 is approximately equal to 14.4, and we're only going to use the positive length there, so 14.4 inches is the unknown side. Now that problem really isn't that interesting. You've probably done things like that in Math 25 before. The problems that are a little bit more interesting are when we actually put some sort of meaning to these distances. And so this next one's kind of interesting. It says that the city of Chicago is located 220 miles north and 136 miles east of St. Louis. So let's draw a picture here. We have St. Louis, might be located right about here. And it says St. Louis, or Chicago, is north and east of St. Louis. So that means it's some distance east and some distance north. So we might say Chicago is right here. It is in fact 229 miles north or above and 136 miles east. And it says, what is the direct distance between Chicago and St. Louis, rounded to the nearest tenth of a mile? So it's asking us to find, really, what we have here is the hypotenuse. We don't know what that is. But we do know that the Pythagorean Theorem will give us that answer really, really easily. So leg squared, 136 squared, plus leg squared, 229 squared, is equal to that direct distance, x squared. We can use our calculators to do some simplifying here. 136 squared is 18,496. And then 229 squared is 52,441. Then we can, of course, combine those two answers. So if we add the 18,496, we end up getting 70,937 is equal to x squared. And again, of course, we take the square root of both sides. So the square root of that last answer is about, the x is 266.3 miles is that direct distance as the bird flies between St. Louis and Chicago. Alright, so that problem's a little bit more interesting. Let's take a look at one more here. It says that a guy wire 40 feet long runs from the top of a pole to a spot on the ground. The height of the pole, that's in our picture here, that's h, is 5 feet more than the distance from the base of the pole to the spot where the guy wire is anchored. So we could call that distance, say, x. We don't know it from the base of the pole, that's right here, to where the guy wire, that's the support wire, touches the ground over here. So that's x. And it says the height is 5 feet more than that distance. So h is 5 feet more than what x is. And it asks us then to find the height. How tall is the pole? Well, this is another example of an application using the Pythagorean Theorem, because we have again a right triangle and we have problems relating the three sides of a right triangle. So we have leg squared, x squared, plus the height squared, but let's call, instead of height squared, let's call this x squared plus, what is h equal to? H is equal to 5 plus x. So we could call this 5 plus x squared. And then 40 squared is 1600. We can multiply this out. Remember that 5 plus x squared means 5 plus x squared means 5 plus x times 5 plus x. So this is 25 plus 5x plus 5x plus x squared, or x squared plus 10x plus 25. So this is x squared plus, we can replace here, x squared plus 10x plus 25 equals 1600, or 2x squared plus 10x. And if we subtract 1600 from both sides, we end up with minus 1575 equals 0. And that might be factorable, but probably do not want to attempt to try to factor that. You're better off using the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. So negative 1575 all over 2 times a, which is negative 10 plus or minus the square root of 100 plus 4 times 2 times 1575. That's a positive 12,600 over 4. Or negative 10 plus or minus the square root of 12,700 over 4, or negative 10 plus or minus the square root of about 112.694 over 4, which is 2 answers. It's negative 10 plus and negative 10 minus. And we can see right away that this answer on the bottom is again going to be our negative one that we don't want to use. But the top one, if we take that and perform the calculation, we get about 25.7. This is equal to about 25.7, which means that the height, remember this was equal to what x was, the height is 5 plus that. So this is about 30.7 feet. That's the height of this power line, 30.7 feet. Rounded to the nearest tenth. All right, and that does it for this section. You should be able to now go ahead and do the self-checks, and we will see you in class. Thank you.